Hello and welcome to the session looking at interfacing between CR-8000 and the Ansys Electronic Desktop. My name's Nicola Kontik and I'll be your host. I'd like to break down the session into three sections. Firstly, an introduction to interfacing with the Ansys Multiphysics simulation tools. Then we'll look at examples of sharing information between CR-8000 and the Ansys Electronic Desktop, the different interfacing methodologies that are available. And finally, we'll conclude on the improvements to the design data exchange available. Looking at the interface between Ansys and Zuken, we have two methodologies to interface. The first method is using the ANF, which is available from DesignForce. From the Analysis tab, we can export an ANF, which will generate both an ANF and a CMP file that can be utilized with tools in the Ansys environment, such as the high-frequency structured solver, SI wave, and IcePack for thermal analysis. Also in the Ansys environment is a tool for the Power Integrity Advisor, and this can analyze the design and provide information for power integrity, which can back annotate information using the BOM file. For that ANF interface, the physical layout information, the layers and any copper on those layers, is reported in the ANF file. Any component information is reported in the CMP file. As you can see in the upper right image, the interface offers the capability to select the type of items to output. Those can be a specific signal or a group of signals, but we can also, from the item on the bottom, auto-generate an area based on selecting a signal or multiple signals and defining an offset distance. So that will specify, as you can see in the image here, select a signal and an area which is hatched around to define into the ANF file. Also, settings can be defined in the parameters file to control, for example, outputting the resist layer. For back annotation into DesignForce, as I mentioned, Power Integrity Advisor can be used in the Ansys environment, and that may define changes for components for decoupling capacitors or even delete some decoupling capacitors. And that information can be back annotated through the BOM file, so we can instigate the import using the item import Power Integrity Advisor in the Ansys menu items from the Analysis tab. And the second method to interfacing is the electronic database. So from within inside DesignForce again, we can export an EDB which can be read by several of the design tools in the Ansys portfolio, those being the IcePack for thermal analysis, SpaceClaim for 3D design, HFSS, and also PI Advisor. Changes can be made inside the Ansys design environment and back annotated into CR-8000 DesignForce. From the CR-8000 2020 release, it's now possible for a layout engineer to generate the EDB output without the need for having Ansys software installed. This makes it much easier for the layout engineer to work independently, generating the EDB information output and passing that on to a simulation engineer who can do the analysis work within the Ansys tools. He can then provide back an updated EDB, and the layout engineer can read that in. The exporting Ansys EDB can be configured for several areas. Firstly, outputting the resist layers or the air layers, how figures will be output in terms of the line output format. Very important depending on which simulation tool we're outputting and planning to use. If you're using SI Wave or HFSS, this is an important selection for you. Similar to the ANF interface, we can specify by signal the areas of the design to analyze, or we can create an area to be sent into the EDB file. And finally, we can control the layers, and with the auto generate area similar to the ANF, we can select one or more signals and define an offset to create the area to be written into an EDB file. Once the simulation engineer has completed the work and generated an updated EDB file, the layout engineer can then import the information into DesignForce. When reading the EDB information, firstly, we recognize the layers inside of the file, so these need to be mapped to the DesignForce layers. Secondly, we can control the type of objects to be imported, tracks, vias, area fill, etc. An important part of this is the responsibility and authority of what information can be imported directly into the electrical information. For example, the manufacturability and vias will be the domain of the layout engineer, and so any changes in this must be approved by the layout engineers. Hence, it's more often that users will import to a documentation layer, review each change by the simulation engineer on a case-by-case basis, and as they're approved, copy the information from the documentation layer to the conductive layer within the design. Moving on to a demonstration of this interface. Within CR-8000 DesignForce, we have the ability to interface to Ansys design and simulation tools. I have a design here which is a power splitter. I have on the far side port 1 and on the near side port 2 and 3 of the splitter, and we have our impedance matching resistor. We have a via which spans layers 1 to 4 with pads on layers 3 and 4, but it has no routing on those particular layers. Within the ribbon there is an analysis tab, and within that the simulation tools. I have an Ansys drop down which allows me to both export and import to and from Ansys analysis tools. I'm going to generate the EDB format, and firstly within inside the setting I can control where the design data should be generated. So I'm going to put it into an Ansys folder within the project area. I can also control whether the resist and the air layers should be output. One important area to note is how figures and lines should be output, whether they should be prioritized by shape or by connection. We need to consider what we want to analyze or what we want to output for simulation into Ansys. That could be just a specific signal we want to look at, or multiple signals. Or we can choose to control it by the layers, so we may only want to output 1 or 2 layers. In my case, I'm going to output all the layers of all the design. A final alternative is to auto-generate an area. And here we would select a signal or multiple signals, but also define an offset, which will then generate an area around those signals to include in the analysis. I've generated the EDB for the entire design, so I can go into the Ansys tool now. And I'm going to import the EDB data into the Ansys Electronic Desktop. Within the project manager, I'll expand the branches, and the top half is the simulation analysis with inside that we want to control and or set up, and the bottom half is to do with the design data. So we have the components in the design, the pad stacks passed, and also the materials, and we can see that the resist and the air layers came through. The Ansys Electronic Desktop and using the EDB format gives us links to HFSS, Q3D, IcePack for thermal, and if we go to the simulation tab, we've got HFSS, SI wave, we've got the DC volt drop, and we've got electromagnetic interference analysis simulation. So that's a benefit using the EDB format. We can also look at other elements of the design. So on the right hand side I have the components panel. I can expand to see the components in the design. Here is my resistor and the properties on the resistor, saying it's a 100 ohm resistor to match the 50 ohms on the 2 ports. We can also see the 3 ports in question, so the left hand side single port and then the splitter to the 2 ports 2 and 3. Inside the Ansys simulation and design tools, we may wish to modify some of the elements in the design. Within this, we're going to make some modifications and pass those back into Design Force. Now, remembering that some elements are controlled and managed, the layout engineer has full authority. For example, manufacturability, we would choose which layer stack to be used and also the vias and the pad stacks. So when I come on to the vias, we'll look at that in a bit more detail. Firstly, I want to make a design modification. I may not be happy with the way this has been routed, so I can make a small modification to this to change the copper geometries. And if I modify this particular one, I'll make a corresponding change to the other output on the power splitter. So I've matched them. I can also look at the properties on any particular object. So here we can see it's a 2 mm width, and I can change that to 1 mm. I'll change these corresponding also to be a 1 mm, and this one to 1 mm. I can do some changes. So this is a power splitter, so the quarter of the wavelength, I want to change some of the length here to adjust it slightly. So I'll modify both to keep both branches matched. And finally, let's just look at the via. So here we have the via that came in from the design. If I click on that, we can see that it's one that came into the project through from Design Force. What I can also do is just have a more representation in the design for it. We can see here that it's got a pad on all 4 layers of 0.35 with an anti-pad of 0.75. As I mentioned, the layout engineer has full responsibility and authority on these elements within inside the design data, But as a simulation engineer, I want to provide recommendations to suppress the pads on conductive layer 3 and 4, or even try to highlight some way that maybe back drilling of the via may be required. So I'm going to change the particular vias to say they only span conductor 1 to conductor 2. So we have several different changes into the design, and I'm happy so far. So I'd like to now save the data, and this time I'm going to call it version 1.1. Now let's toggle back into Design Force, and from the same Analysis tab I'm going to perform the Import EDB. Within this I need to select the folder where I generated the new EDB data. Inside the layer mapping, it's analyzed the design, recognize that there are 4 layers, and I now need to choose how I want to map those. Now once again, the layer engineer has authority on any changes, so I'm going to import them to a documentation layer corresponding to the conductive layer. I can control what items to be imported, but let's go ahead and import them. If I now go and change some of the settings on my documentation layers, and let's define them as a tonal pattern with a purple color. Okay, so we'll have a quick look at the documentation one there. So here we can see the design changes that I could have made to my design in the Ansys tool. We can see some of the geometry changes for the copper. If I look at my conductive 2 layer equivalent, which is in documentation 2, I can see the information. If I turn off my conductive layers, I can also then just toggle, and we can see that there is no longer a pad on conductive layer 3 required, or a conductive pad on layer 4 required. So it's documented that there is no need for that. But once again, I can toggle back and see my design with the conductive 1, 2 and 3 layers I can turn on. So that's imported information back into the PCB design, and now the layout engineer can review the information corresponding to those conductive layers as specified by the simulation engineer. Now let's look at some of the improvements in the interface. With regard to using SI Wave, some of the information can be displayed inside of Design Force. Using the advanced integration available and the Zuken's partnership and alliance with Ansys, we can display the DC volt drop information directly inside of Design Force, and also the frequency sweep information inside of Design Force. Finally, some of the information that can be extracted also from SI Wave, such as the parasitic information for tracks, can be annotated and generated into parasitic element models, which can then be imported into the SPICE simulation environment. Initially, a circuit engineer may have performed a functional verification simulation on the design. Once the physical information is created, we can extract the parasitics, generate those parasitic element models, and add that to the circuit information so we can do a much more enhanced functional verification using SPICE. In summary, I've introduced you to the interfaces to Ansys from the Zuken CR-8000 tools utilizing the ANF and the EDB. The EDB being a single data exchange and the more recent bidirectional interface. The alliance and partnership between Ansys and Zuken provides an enriched interface. It's available for sharing data bidirectionally, performing design changes in either the Ansys environment or the Zuken environment, and very quickly sharing the information. Also, using SI wave, for example, we can display the results for the DC volt drop or the frequency sweep directly inside of Design Force. Once we have a physical layout, information from SI wave can generate the parasitic element models for the tracks on the PCB, and this can be added to the functional verification performed using SPICE from the circuit design aspect. These interfaces between CR-8000 and Ansys provides an efficient and productive design environment. It allows the engineers to perform a verification at various points in the design process, making it very easy to perform design reviews, design changes at any of the design tools or simulation tools, giving a very productive design environment, improving the product quality of the designs being created and of the products. Thank you for your time.